Welcome back to another video, you guys. Today we're going to be doing series and parallel resistances. I hope you enjoy. Welcome back to a quick video by Takmir. So if we look at resistances, now what is resistance? Resistance is opposition to current flow. So it restricts current flow. So now let's go look at a series resistance. This would mean your power comes in and it meets the resistance and it flows out of that one element. That would mean a series resistance. Now, a parallel resistance. Okay, let's go look at two series or three series. Like, let's go look at 1, 2, 3. Sorry about the grass looking stuff, but you guys get the memo. It is 3 in series. So this is a 3 series, the top is a 1 series, and we can draw 100 in series. You guys get the message. So the next one is going to be parallel. Let's just scroll up a little bit. The next one's going to be called parallel. So we'll have 1. Okay. What's going to be different? How are we going to do this? Okay. So you can picture it drawing it above the other one as well. Drawing a line and then linking them. And then this would be the easiest way to remember parallel. Right now, let's go and look at, again, the 10-volt source. Right? Feeding a resistor. Right? This is ground. So let's make this a 5 ohm resistor. Now, according to Ohm's law, right, this would pull 2 amps. So you'd have 2 amps. Why 2 amps? Because it's V divided by R is I, right? This is one of Ohm's law's principles. So V divided by R is I, which is 2, which is 2 amps. Right? Simple. Let's go and look at this. If I have two 5 ohm resistors and the source here of 10 volts, right? 5, 5. What happens? What happens? How do I get the total resistance for this value over here? You add them. It's additive. Okay. Series is the easiest with the resistors. 5 plus 5 is 10. The new value in total is 10 ohms. So 10 volts divided by 10 ohms is 1 amp. Here we kind of see the definition of what a resistor is. It opposes current flow. So now we have a little bit of the definition baked in. All right, so let's go to parallel. Parallel is a different beast, but we'll start off with the same 10-volt supply coming in over here. I will use IEC references later to the suppliers and stuff. I just draw them in a fun way, I guess, and it also works, of course, to illustrate the principles. So now let's go parallel. We're going to do 5 ohms again. We're going to do 5 ohms again. Let's just keep it at 2. I'm just going to cancel this one. We can parallel even further later. And then let's ground them. So, okay, what's going to happen here is, mathematically, what you're going to do is, you're going to say 1 over RT is equal to 1 over R1 plus 1 over R2, right? You have two resistances, and this is the parallel resistance formula. So now let's go look at it. 1 over RT, so it's like, okay, cool. It's pretty easy what you have to do to just get RT as you flip it. But then, of course, you have to flip the other side. So let's calculate it. 1 over 5 plus 1 over 5 is equal to 2 over 5, right? 2 over 5 is 1 over RT, right? Is equal to 2 over 5, because obviously the denominators are exactly the same, right? So we can do this. Now, RT is, what did you do here? You flipped RT over 1, right? And then you can do the same on this side. And this is equal to 2, 5 resistance total. right? Ohms. Okay, so obviously calculation a little bit longer in parallel. Now let's go see what happened with the total amperage of the circuit. So if we calculate RT, which is the total resistance of the circuit, we have our source voltage, which is 10. So let's go and calculate the amps. 10 divided by 2,5 equals 4. Why? Because that was the voltage given. 2,5 is the resistance. And of course, 4 amps is then pulled by the circuit. Obviously, the bottom line take from this is the fact that series resistors are added and parallel resistors are basically calculated using the parallel formula, which is this. Here's the parallel formula over there. Now we've looked at that.